Let's talk about factoring. Okay? First thing I want you to realize is that factoring and dividing are similar. Okay? They are not the same. Long division, synthetic division, that's when I give you a polynomial and ask you to divide it by a certain thing. You either have to use long division or you have to use synthetic division, right? Okay? But when I ask you to factor something, I'm asking you to take it down into its pieces and parts, but I'm not giving you anything to start with. Does that make sense? Okay? So if I said, what are the factors of 10? Well, what are the factors of 10? 2 and 5, is that it? 1 and 10? Is there anything else? What about 10 and 1? What about 5 and 2? The factors of 10, right? Okay? So, there's one thing that we need to start off with every time when we're talking about factoring polynomials. Okay? Let's start off with this example. 2x plus 4. If we're starting off with this example, what do you notice about those two terms? They're both divisible by 2, aren't they? Okay? So what if I factored out a 2 or divided each term by 2? What would I have left if I divided a 2x by a 2? Let me ask that question again because I think you're not listening, right? What do you get when you factor out a 2x by 2? An x, right? That's what I get as x. Because basically what I'm saying is 2x divided by 2, right? Now, I know what I said was let's factor out a 2, but remember what did I tell you at the very beginning? Factoring and dividing are similar, right? And in this case, we are factoring out a 2 by dividing each term by 2. Does that make sense? Okay? So now what's left if I divide this term by 2? 2. Now, are you noticing that we're going term by term? So do I want you to shout out the whole answer?
No.
Do I literally ever want you to shout out the whole answer?
No.
No. Okay, so please don't do that. All right? What about this? Don't write this one down yet. Not quite yet. Okay? What do you notice about this? They're both divisible by 4, right? But this is not the problem I'm going to give you to do. This is the problem I'm going to give you to do. Oh man, I'm not a man.
You're right.
Are they still both divisible by 4? Yes, right? As the constants, the coefficients, both of those numbers are both still divisible by 4. So we are going to still factor out of 4. The difference now is that both terms have an x. And when I'm looking for the greatest common factor, what am I going to end up looking for? The smallest x, right? Doesn't that seem weird if I'm trying to find the greatest common factor? That I would look for the smallest exponent? Well, not at all, right? Because I can't divide an x squared into each term, can I? I can divide the first term by x squared. I cannot divide the second term by x squared because the second term only has an x. Does that make sense? So do you see now that the greatest common factor is 4x? Okay? So what's left if I divide the first term by 4x? X. What's left if I divide the second term by 4x? 4. So 4x times x plus 4? Is there any, I'm sorry? Is there anything I can divide out of this term, like anything else? Like that maybe I missed the first time? No, so this is the answer, right? All right, then let's go here. 3xy squared plus 9xy minus 12x squared y. Dang. Look at just the coefficients first. Okay? If you are just looking for the coefficients first, I'm going to ask a question. I want you to at least wait 3 seconds before anyone calls out the answer. Okay? It's called think time. It's giving everybody a chance to think. I'm going to ask the question, and then I'm going to count to 3 before anyone answers the question. Is that fair? Okay? what are all three of those numbers divisible by? 1, 2, 3, right? Okay? So does it make sense that 3 would be at least part of the greatest common factor? Do all three terms have something else in common? Oh, they all have an x? Well, this one has an x squared. Yeah, you're right. So, right? So, that's great that it has an x squared, but they all have an x, so x is all I can factor out of all three of them. What else do they all have? A y. Well, this has a y squared. So, right? They all have a y. That's what I can factor out. Okay? Now, I very nervously am going to ask you a question. What is 3xy squared divided by 3xy? Oh, that makes me so happy. You know what people say sometimes? Squared. You know that's not right, right? 3xy squared divided by 3xy. The 3 simplify to 1, the x's simplify to 1, y squared divided by y simplifies to y, not squared, right? So y. What about 9xy divided by 3xy? Oh, just 3, right? Okay, because what happens with the x's? They simplify to 1. And what happens with the y's? They simplify to 1. Guys, can you hear me correcting your vocabulary? I'm doing it purposely. I need to make sure you understand, right? Because remember we had this conversation last week? We can't just say cancel anymore because you're meaning two different things, so we're making sure our vocabulary is accurate, right? Okay? And then 12x squared y divided by 3xy? 4x. Now, did that seem difficult at first? Oh, some people say no. Some people say yes. That's fine. If you're a no, that's great. But if you were a yes, was it actually that difficult? No, we just took one part at a time. Remember when I kind of got mad at you at the beginning because you wanted to do it all at once? Because I knew these questions were coming up and I needed to make sure we could do one at a time. Is that fair? Okay. So every single one of these problems, we're going to start with finding what? Greatest common factor. Okay? Greatest common factor. Now, after we find greatest common factor, there's tons and tons of ways you can factor. Okay? Today we're going to cover 5 of them. What does that mean about those 5? Real quick. They're real quick. Okay? And I don't want to say the E word because you guys don't ever believe me when I say the E word. Yeah? You guys can tell me if they are or not, right? But let's start here. One way you can factor something is if you recognize that it is the difference of squares. Well, before we can recognize whether something's the difference of squares, we need to make sure we know what that means, right? Math-wise, what does this word mean? Subtract, right? Yeah. Math-wise, what does this word mean? A number you can take the square root of, right? So can you give me some examples of a square? 4, 16, 9, 25. You get the idea, right? Numbers that you know the square root of, right? 100. What do you say? 36? Yes. Okay? So do you get the idea? The difference of squares is going to be 2 numbers that you know the square root of that you're subtracting. Everybody okay with that? Okay? So for example, x squared minus 64. X squared minus 64 is the difference of squares. Do you recognize it as the difference of squares? Like if I just gave you this problem, could you tell me, oh, that's the difference of squares? Well, is there a subtraction sum between the two terms? Is x squared a squared term? That seems a little silly to ask because it literally says x squared, right? And then what about 64? Yes? Okay. Now, let me tell you how I feel about formulas. Okay? Formulas are great, aren't they? They make our life easier because we can plug numbers into a formula and get an answer. We don't have to do it the long way every single time, right? I hate memorizing formulas.
Right.
This school year, I'm going to ask you to memorize one formula. One.
Why does it need to be?
No, you already knew that one. Okay? There is a formula for this. If you'd like me to write down the formula for it, I could write it down after thinking about it, because what I know is the pattern. And I'd rather you know the pattern than the formula. Because if I teach you the pattern, you're going to be able to do all the rest of them really quickly.
Ooh.
But memorizing the formula, it just seems real cumbersome. Okay, so can I teach you the pattern?
Yes.
If I ask you to factor the difference of squares, or if I ask you to factor a polynomial and it happens to be a difference of squares, you're going to already write down two binomials. How did I make sure you knew it was a binomial? Yeah, I put in the lines, right? We're basically going to fill in the blank, aren't we? Okay? Okay, are you ready for the pattern? What's the square root of the first term? X. Then it goes at the beginning of both binomials. What's the square root of the last term? 8. It goes at the end of both binomials. All we have left are signs, right?
Oh, no.
Yeah, they're just opposite. If the first one's plus, the second one's minus. If the first one's minus, the second one's plus. Does it matter what order I put them in? It does not. Okay? Now, if your instructions are factor completely, which is what they always will be, factor completely, we're done. Okay? Can I prove to you, however, that this pattern works? Are you okay with that? So you don't have to write down this part unless you just want to write down the proof. But this is not required as work. Does that make sense? What would happen if I multiplied this back out? Shouldn't I get the original problem? Okay, so what's x times x? X squared. What's x times 8? Plus 8x. What's negative 8 times x? Negative 8x. And what is negative 8 times 8? Negative 64. What happens right here? That's 0, isn't it? 8x minus 8x, and what do I have left? X squared minus 64. You see how the pattern works?
I see that.
Because they're opposite signs, it serves to cancel out. Oh, that was bad, right? I just said it. It serves to make these two terms go to 0. Yes,
Do you have
sir.
Madison Allgood?
Yes, I do.
Could you send her to the age pack?
Yes, I will.
Thank you. For senior pictures.
Thank you.
She said cancel out.
I did. I admitted it very quickly, didn't I?
Mm-hmm.
Okay.
And I said, yeah.
Can we do another one? Yes? Okay. Now, a lot of people say that the hardest part is recognizing that it's the difference of squares. Right? Because they see two things, and the first thing you want to try is greatest common factor, which is good. Right? Do these two terms have a greatest common factor?
No.
They don't, right? They're both not divisible by the same thing. Well, if they don't have a greatest common factor, there's two terms. What should I look at? First of all, is it a difference? Is it one term minus another term? Yes. And are both of these squares? Well, if that's true, I should get two binomials, right? What goes at the beginning of each binomial? 2x. What goes at the end of each binomial? 9. And what about signs? Yeah, they're just opposite. Now, I did something on purpose. Did you notice it? The first example I did, I put a minus first and then a plus. This example that I just did, I put a plus first and then a minus. I really want you to understand that it doesn't make a difference which one is plus and which one's minus as long as you have one of each. Does that make sense? Okay, can I try to trick you? Yes? Okay. 4x squared minus 100. What should you do first? Oh, there's the greatest common factor, right?
Yeah.
So you didn't get tricked? Good. So what's the greatest common factor? 4. Well, first of all, can we back up just a second? Is this a difference of squares?
Yes.
It is. Right, so some people want to go straight to the binomials. I'll show you in a second why we shouldn't do that. Okay? Well, it's not wrong, it's just more steps. Is that fair? Okay? So if I factor out a 4 first, is that all I can factor out is just a 4?
Mm-hmm.
Yes? Okay. What do I have left if I factor out a 4? X squared? 25. Good. Is this the difference of squares? Yes, it is. So what should my binomials say?
Squared.
X5.
So x minus 5 and x plus 5? Because the square root of the first goes at the beginning of each binomial. The square root of the last goes at the end of each binomial, and they are opposite signs. Can I try to trick you again? Yes? Okay. Awesome. I can try. Okay. 4x squared plus 64. What do you want to do first? Oh, greatest common factor. Okay, so if I divide out a 4, what's left? X squared plus 16. Okay. 2 binomials? Oh, it's different then, right? So I might have fooled some of you because some of you are already writing 2 binomials, but I didn't fool him. Because what he said was positive. Is this the difference of squares? What is it? Yeah, I can only add one more letter. The sum, right? The sum of squares?
That's the next step.
It is. It's the next one. It's one of my favorites. You know why? Because for us in Algebra 2, we can't factor it. The sum of squares is prime. We can't take it down to any further factors. Now, college algebra we do, but in Algebra 2, high school Algebra 2, when we see the sum of squares, we write prime and we go to the next problem. Okay? Can I show you why this doesn't work? In order to get a plus 16, what has to be true about these 2 signs? They have to be the same, right? They could either be positive both or negative both, right? But in order to get a positive 16, they have to be the same. Well, if it was x plus 4 and x plus 4, x squared plus 4x plus 4x plus 16. And while I have the x squared and the 16, what doesn't happen right here? They don't go to 0, do they? That's 8x. These middle 2 terms don't go to 0. So x plus 4 times x plus 4 does not work. Guess what's going to happen for x minus 4 and x minus 4? Same thing, but this is going to be a minus 8x, right? These 2 are still not going to go to 0. I'm still going to have a middle term. That's why this is prime. Everybody understand? Okay, so we've already done 2 ways. You ready for the last 3? We'll do them one at a time. Maybe. Difference of cubes. So what's going to happen? So it's going to be another binomial, right? What's going to be the sign between the 2 terms? Or between the 2 binomials? A minus, because it's a difference, right? But the difference this time is that they're not going to be squared terms, they're going to be cubes. So x cubed minus How about 8? Is 8 a cubed term? What times what times what equals 8? 2, right? So you may teach the pattern or the formula.
Whichever is easiest.
Pattern, okay? So when we had difference of squares, let me show you real fast. Difference of squares, I had what? 2 what? Binomials, okay? When I have the difference of cubes, I'm going to have a binomial,
3.
but I'm going to have a trinomial second. Got it? A binomial and a trinomial. Now, the binomial is, I think, what you expect it to be. Okay? And we're going to use the binomial to give us the trinomial. We're not going to work any harder than we have to. Okay? So what do you think ought to go in the binomial? X and what? And 2? Well, isn't that the cube root of the first term? And isn't that the cube root of the last term? Yes, so we want the cube root of the first term and the cube root of the last term in the binomial. What did I purposely not put in there? A sign, right? I'm going to leave that to the end. Okay? Cube root here, cube root here. Is everybody okay with that? Now, like I said, we're going to use the binomial to get to the trinomial. Okay? So the first term in the trinomial is this first term squared. So x squared. The middle term in the trinomial is these two multiplied. 2x. And the last term in the trinomial is the second term squared. So 4.
Wait, the second term what? You said what?
First term is the first term squared. Second term is first times the second. Last term is the second term squared. Does that make sense? Yes or no? Last thing we have to do is add in the signs. Now, when I'm adding in the signs, I'm adding them in the spaces. I know that this term needs a sign and this term needs a sign, but because of how these problems are set up, all we have to worry about is this one, and this one. You okay with that? Okay. The sign of the binomial is the exact same sign that was in the problem. The next sign is the opposite of that. And the last sign, always plus. And that's it. And if you multiplied this all out, guess what you would get? X cubed minus 8, because the squared term and the x term would both go to 0. Do I need to prove that to you?
Nope.
No? You just believe me? Thank you. That's kind. Everybody okay so far? 27 x to the third minus 64 y to the third. Question number 1. Is there a greatest common factor that I can take out? Are they both divisible by 3? They are not. This one is. Guys, do you know the quick shortcut to know if a number is divisible by 3? Do you know if 27 is divisible by 3, first of all? You know it is, right? So this trick should work, right? What's 2 plus 7? 9. Is 9 divisible by 3? Then so is this number. Do you know if 100 is divisible by 3? It's not, right? 99 is, but 100 is not. So what's 1 plus 0 plus 0? 1. Is 1 divisible by 3? Then neither is 100. 99. You just told me you knew that 99 was divisible by 3, right? What's 9 plus 9? 18. Is 18 divisible by 3? Then so is 99. So is 64 divisible by 3? Well, what's 6 plus 4? 10. Is 10 divisible by 3? Then neither is 64. There's some number facts maybe that you didn't know before. Is that good? So so you just told me there was no greatest common factor, right? Next thing to recognize, is this the difference of cubes? Well, what times what times what equals 27? If it is a cube, we can figure out what that what is. 3? 3 times 3 is 9. 9 times 3? 27. So 27 is a cube, right? Is 64 a cube? What times what times what equals 64? 4 times 4 is 16. 16 times 4 is 64. So is 64y cubed a cube? Yes. So I'm going to get a binomial and a trinomial. Got it? What goes in the first term of my binomial? Cube root of this first term. What is the cube root of this first term? 3x. Very good. What goes in the second term of the binomial? Oh, the cube root of this term? What is the cube root of this term? 4y. Okay, trinomial, you ready? First term, squared. Don't let yourself be tricked. What is 3x times 3x? 9x squared, right? We don't want to miss the multiplying the 3's together, right? Okay. How do we get the second term in the trinomial? Multiply these together. So what's 3x times 4y? 12xy. And how do we get the third term in the trinomial? Square 4y. What do you get? 16y squared. Now for the signs. What's the sign in the problem? Sign in the binomial. Opposite. Always plus. Sum of cubes. You ready? I think you could do this without my help. You know why I think you could do it without my help? It's exactly the same pattern as difference of cubes. Because of how I taught you the pattern of difference of cubes, you also know the sum of cubes. Now, some of you are thinking, I was hoping it would be like sum of squares, right? Because that would be prime and we rewrite prime and we'd go on, right? Sum of cubes can be factored. So walk me through it. What are we going to get? Binomial, trinomial. First term of the binomial? 5a squared. Yes. Because a squared times a squared times a squared is a to the 6th, right? Because when we're multiplying like bases, we add the exponents, right? 2, 4, 6. Second term in the binomial? B. First term in the trinomial? First binomial squared, 25, a to the 4th. Very, very good. Second term in the trinomial, 5a squared b. Excellent. Third term in the trinomial, b squared. Signs? Why? Why is this one plus? It's the one from the problem. What's the next one? Negative, because it's opposite of the first one. And then the last one? Positive. It's always plus. Good. Got it? All right, so that's 4 ways. You ready for the last one? We're going to factor by grouping. Okay? We're going to factor by grouping. Now, the best way for you to know how to factor by grouping is what? How many terms are there? 4. When there's 4 terms, we always want to try to factor by grouping first, right? Actually, what do we want to try first? Oh, greatest common factor, right? We always want to try greatest common factor first. That can make our life easier. But then, when we realize there's no greatest common factor, we notice there's 4 terms. Okay? If there's 4 terms, we want to try to factor this by grouping. Now, factoring by grouping implies that we're going to what? Group things, right? What we're going to group together is the first 2 terms and the last 2 terms. So I'm literally going to ignore the last 2 terms for a second. Do the first 2 terms have a greatest common factor? What is it? 2x squared. Is everybody okay with that? So if I factor out a 2x squared only from the first 2 terms, what do I have left? What's this term divided by 2x squared? X. What's this term divided by 2x squared? 5. Are you comfortable with that? Then we're going to ignore those 2 terms and just look at the last 2 terms. Do these 2 terms have a greatest common factor? What is it? 3. What's left if I divide each term by 3? What's left if I divide the first term by 3? X. What's left if I divide this last term by 3? Plus 5. Everybody okay so far? You're comfortable with this? Now, I'm going to look at the first term and the second term. Do these 2 terms have a common factor? Oh, they do, don't they? What is it? X plus 5. What's left if I divide each term by x plus 5? 2x squared plus 3. Done. There's 4 terms. I group them. 2 and 2. I look at the first 2, take out a greatest common factor. I look at the last 2, take out a greatest common factor. I look at these 2 terms, take out a greatest common factor. What's left is my other factor. Got it? Can I try to trick you? X cubed plus x squared plus x plus 1. I got to do this one pretty quick, yes? What's common in the first 2? X squared. What's left if I divide each term by x squared? X plus 1, right? What's common in the last 2? Knowing I have to take something out. That's all I can take out, right? A 1. What's common? Or excuse me, what's left if I divide each term by 1? X plus 1. Do these 2 terms have a common factor? X plus 1. And what's left if I divide out an x plus 1? X squared plus 1. Got it? Any questions? Be careful that you don't get here and see that this is the difference of squares. Because if it is, you're not done, are you? If this said x squared minus 1 right here, wouldn't I need to factor that as the difference of squares after that? So just be careful about that, okay?